All right, so this week I wanted to cover a couple different things, but I'll start out with a topic called shift registers. And the deal with shift registers is in LabVIEW there's a couple things that don't quite match up as nicely as in a text-based language. And so one of them is, suppose I want to look at a value in a loop somewhere. And so maybe this is something like I want to have a running sum. So basically, every time the loop executes, I take what's there and add it to the existing sum, and then I just keep doing that. And in a text-based language, that's really easy to do. But in LabVIEW, it's a little bit more difficult, and I'll show you what I mean. So suppose I've got a numeric, and I'm going to put a while loop in, and maybe I'll put a numeric indicator. And just because I can, put this guy in constant. And really, there's no way I'll bring this in the loop. There's no way to add my new number to our existing sum. And so in a text-based language, this is really easy. But in LabVIEW, it's a little bit more difficult. So we end up having to use this thing called a shift register. And the way a shift register works is if I go over here where it says loop tunnel, hover over it, if I right click on it, I can say replace with shift register. And you'll notice that another one pops up over here. And the way to think of this is anything I put into the shift register over here on the right side, the next time the loop executes, it's going to come out over here on the left side. So every time this loop runs, it's going to take whatever value's here, it's going to add whatever number I've got to it, put that together, and then it's going to store that into the shift register. So the next time this executes, it'll go through again and again. So it's kind of an inconvenient way to do things, but it's how we have to do them. So what I'm going to do, I'm going to change some things up here, and this will probably be one of your assignments here. I'm just going to Control B and get rid of all the broken things, including this broken shift register. What's probably a little more useful is maybe sometimes when I'm collecting data, instead of getting like kind of a really bumpy signal where I just have bunches of things happening, sometimes it's a little better to be able to do like a little bit of data smoothing. And this is a very, very delicate thing, but for now, let's just pretend I need to take a running average. Right now, you're seeing this in the news when they talk about the number of COVID cases, and they say, oh, we're doing a 7-day average. And so what they're doing is they're basically taking today's average and the previous 6 days and averaging them together and reporting that number. And then when we go to tomorrow, it'll be tomorrow plus today plus another 5 days behind us, or the previous 5 days. And it's basically a running average of 7 days. Now, I don't want that. I want a running average of 3. So I'm going to put a knob in here, and I'll put a graph or a waveform chart. I'll put the knob in the loop and the chart in the loop. Isn't that fun? And so what I want to do is I'm going to do a couple things here just to demonstrate. I'm going to do bundle. I'll show you about that in a little bit. But then I'm going to go ahead and do my average. So what I'm going to do to get a running average from this data point and the previous 2 is I'm going to run one there. And actually what I'm going to do is I'm going to display both. I should back up. I'm going to display both our current average and our 3-point average. So I'll run a wire here. So what I've done is basically said, well, I'll go through that part in a minute. I'll just a little disorganized tonight, but we'll get it. Okay, so this is going to be my average, so I'm going to run it here. I'm also going to take the average. Oops. I'm also going to take my data point. Oops, that's not an average, is it? That's just a sum. Let's do an average. We'll do divided by 3. Okay. So what I've got is basically this loop executes. It takes a number. It's going to add it to some stuff and divide by 3, and that's going to be our output to our chart. The other thing I'm going to do is I'm going to take this. I'm going to run it over to the side here, and I'm going to make what's called the shift register. Now, what this does is if you think of this loop as being loop number n, when this loop runs, this data point is going to be basically n minus 1. It's going to be the value that was there during the previous loop. So that's a good one to have. And rather than doing another shift register, there's this thing called adding a register, or adding a element. I'm sorry, adding an element. So if you right click on this, see where it says add an element? And so basically it's like, this is the value from n, you know, our current loop iteration. This is the value from the last loop iteration. And this is the value from 2 iterations ago. And that's just a hot mess. I'm going to try to make those wires not be on top of each other like that. Make them socially distant. Okay. So what does all this look like? Oh, and so basically I add our current value, our previous value, and the value before that. Divide them by 3. So this part just takes an average. And then I run it to this cluster and then run it to our output chart. So the other thing I'm going to do is I'm going to make our chart show both of our graphs here. This is exciting. Hope you guys are enjoying this. All right. So now what's going to happen is our white line is going to be our current value, and our red line is going to be the 3-point average. And somewhere along here I got a broken wire. Oh. Yeah, I made this fancy while loop and I did not put a stop button. Okay, so now we can stop this thing if we want. And it's all very ugly. Play with it and make it not so ugly. But now I'll run this. And you see, the white line is our current value, so it's going pretty quick. But then our red value is averaged against the previous 2. And so it lags just a little bit. And so this is, like I say, with COVID, this is how they're doing the case counts. So if we have a spike for a day, in the case of COVID, it's a 7-day average, but I think you get the idea. So so suppose you've got some data that's like kind of bouncing around. Maybe you want to use the averaged 3 values as a way to kind of smooth that out a little bit. And you just have to use your engineering knowledge of the situation to see if that's an appropriate thing to do. So that's shift registers. You can think of it kind of like Pac-Man. You know, when you're like running from the ghosts. You guys are probably all too young for Pac-Man, but when you're running from the ghosts and you go out the exit on the one side, you come out over here, and the ghosts are all fooled. So that's basically how shift register works.